Hey everybody, my name's Alex. Here to talk about Ember concurrency, which is something that I've been talking about for a good 6 months now. Maybe a quick show of hands who here has used it before? Okay, good number, about half, maybe a third. And so I've given a version of this presentation and it's been sort of refined bits and pieces over time, but fortunately I feel like I don't have to like convince people or make the case anymore. It's just generally seems to be accepted by the community, and hopefully I can just teach whoever's interested to teach some people to start using it and maybe refine some practices, but also this time talk a little bit about like where things are headed with Ember concurrency, because for the most part I haven't really changed it fundamentally since like February. So without further ado, Ember concurrency, what is it? Well, it's an Ember add-on. It was released back in February, and it gives you powerful primitives for dealing with asynchrony and concurrency in your Ember apps. And if you look at Ember Observer, which is a great collection, and basically every Ember add-on that's ever been created, it rates them and basically gives them a score based on how well they're maintained, who uses it and whatnot. And Ember concurrency, depending on like the tides of NPM installs, like goes in and out of top 10, and I think right now it's about 13. So a lot of people are using it, and so definitely caught on pretty quickly. So before I get into some like API, like what the stuff actually looks like, I just want to say Ember concurrency gives you a thing called structured concurrency, which isn't anything that I coined by any means. There's a great blog post about it, specifically how it's been used to make some like, to emulate like a C library that does what like the Go language does. But structured concurrency just means that if you've got a long living process that spins up another long living process beneath it, that child process doesn't outlive the parent, because usually that means it's lived beyond its lifespan and it might be accessing data that it shouldn't be accessing anymore. And it's a really reasonably simple concept, but in the way that it relates to Ember apps is usually you have a component that's rendered, it kicks off some asynchronous operation, but then if the user navigates away to a different page, you need to unrender that component and make sure that whatever operation was kicked off also knows to stop, because if you don't, then maybe some callback fires and you try to set some properties on the object that doesn't exist anymore, and it's like every framework's got their own version of like what that error looks like, but it's a really annoying thing. It's pretty hard to kind of box in without the right tools. So that's kind of one of the things that the main sort of central thing that Ember concurrency gives you. And as a corollary, it gives you cancellation. Like if it's going to promise to say that it's not going to let these child processes live beyond a parent process, that means those child processes need to be cancelable in a way that if anyone's ever tried to use promises don't really give you that. So Ember concurrency gives you something else. So it gives you a cancellation and make sure that async lifespans are constrained by cancellation. You know, if you're going to make the thing in the top look at the thing in the bottom, that blue part at the bottom is actually is a process that gets canceled. So promises aren't cancelable. There's a specification that is slowly making the rounds as to how to make promises and async functions cancelable, and I don't know if what's there has the proper consensus to keep on going, but they're getting closer to an answer. But until then, we need something else so we can build our apps. So some symptoms that you might get something out of this Ember add-on. One is that if you find yourself checking if this is destroyed, if you find yourself checking that a lot, chances are you're doing that because some callback is fired beyond a component's life cycle. Same with that, if you don't want to write is destroyed, but you want to be very careful to cancel every single timer that you might kick off in the process of a component being alive, but then make sure you cancel it when it's unrendered, then you might use something like clear timeout or ember.run.cancel. Just basically a bunch of defensive programming guards that you wish you didn't have to write. And you might do something like that in a will destroy hook. Will destroy hooks usually mean some kind of cleanup that, you know, if they're an alternative, it'd be nice to not have to write that stuff. Or if you have some logic that's, you know, for every single callback in like a chain of promises, if you're checking like, was I canceled? Okay, no, keep going. Was I canceled? Was I canceled? Then that's, you know, chances are you're going to get something out of this. So it's basically, if you find yourself writing all sorts of like very careful, meticulous guards to make sure that some child task hasn't lived beyond a parent, then EC might be the answer. So to sort of give you a before and after, this is an implementation of this button here. And all it does, it's a button that you press it, it goes into a sort of clicked state to sort of display that it's not clickable thereafter. It does some like asynchronous operation, comes up with a value, and then kind of writes it to the component so that it's visible in the template, so that the answer is visible in the template. But you know, a lot of guides that teach you how to do Ember aren't going to go into this much detail about it. They might have the part where you set is idle to false. Maybe they'll have the part where you fetch data and do that then. But it's really annoying when you actually have to make something that's production ready, because you got to put all these guards everywhere. You got to say, has this component been destroyed? Also, if you keep on clicking, you can't really see that I'm doing it. But if I'm tapping the button over and over again, you kind of need to check, like, am I already running? If so, then like return early. And it's all this annoying stuff, but you have to do it if you're actually going to make a production app. And it makes all the the code examples of any framework, for the most part, look pretty crappy. But that's what production code can look like. So that's the before, and this is the after if you're going to rewrite the exact same thing using an Ember concurrency task, which I'll go into more detail in just a moment. But in this case, you have a thing called refresh data. It's a task. It uses this new generator function syntax, which I'll talk about in a second. You call that same fetch data function, but you basically pause the task right here, and then when the data comes back, you write it to the component just like you did before. And it might not look like it, but all those subtle semantics, things that used to be safely guarded with if is destroyed or if task is already running, return early, all these things you don't have to write, except it does exactly the same thing. It's the exact same implementation, does all the same things as what the previous slide did. So before, after. And so the key primitive that Ember concurrency gives you is this thing called a task. And a task is something that kind of should feel a little bit like a computed, like the way you specify it. It's like instead of computed, you'd say task and you pass it a function, but it's not just any old function, it's this generator function syntax, which is a more recent addition to JavaScript, but it's totally fine for you to use it in your Ember apps because it can be transpiled by Ember CLI back into a format that older browsers also know how to use. So there's no risk that you're going to be using this nice new shiny feature of Ember concurrency, but it's not going to work in older apps. It's just totally fine because it's going to get transpiled. And so what this task does is basically it's going to set header to 1, it's going to wait for a second, set header to 2, wait another second, set header to 3, and then it's done. And that's what it looks like. And for what it's worth, this timeout function right here is just, it returns a promise that resolves in 1 second, or how much time that you give it. So basically, what you might begin to see is that every time you see this yield keyword, which is something that is specific to generator functions, it's an opportunity to pass it a promise that it's going to pause at until that promise is resolved and then continue running from here. And if that seems like some magical JavaScript stuff, like the whole reason that works is because generator functions are a thing. Generator function makes it possible to start running a function, pause at a yield, and then resume it at a later time. It just so happens to be that Ember concurrency does it in a way that like inverts the usual way of thinking about it and lets you basically take control with this generator function and just define all these times that you want to pause and come back to it, but in a very like synchronous looking fashion, even though stuff is happening involving time. It's asynchronous. So yeah, very simple thing that it does, but that's sort of your introduction to a task. Also, I guess I have an example of this here. If you wanted to cancel the task halfway through, you could do that by tapping cancel. It calls a cancel all helper, which knows how to cancel any running tasks. So that's like a really hard thing to implement just with promises because promises don't cancel. So tasks, they're not quite just like functions. You have to grab an instance of the task off the object and call perform on it or use the perform helper. They're cancelable. They're implemented with these generator functions, which are totally safe to use and totally backwards compatible to use. And to pause a task at some line of code like it does here, you just use the yield keyword and give it a promise. And when the promise resolves, then it continues running. And so this lets you do some pretty interesting things that wouldn't really make sense if you were trying to think about how to implement similar things with like a promise chain. So here's a task called myTask. It uses generator function syntax, gets an array of words, and it loops through each word and then writes one word at a time to this header field, and then it pauses 1 second per loop. So it's literally the same thing from the previous slide, but rolled up into a single loop. So this should seem a little strange if you've never seen a generator function syntax before and exactly how it can pause literally anywhere within a function. But again, that's all the magic of generators, and Ember concurrency just uses it in an interesting way. Of course, cancellation works as well on this slide than it did on the previous one. And this is just another example of using loops, but using the sort of iterator API of JavaScript or ES6. Same thing as the previous slide. So that's what a task looks like. That's what Ember concurrency gives you, but there's definitely a lot more to it. And as a sort of case in point of how flexible and how they apply to a bunch of different problems, like all of these slides, this whole presentation, it's not like Keynote or anything. It's just like a little web page running an Ember app, and these are actually running live code, but it's running within these components. Like each slide is a component. So when I go to a different page and I still leave this 1, 2, 3 loop running, it doesn't cause any havoc or throw any errors or anything like that, because a timer fired beyond some lifespan of a component, it just cleans up after itself. So none of them implement will destroy element, none of them cancel timers, none of them check is destroyed. They just use tasks, and that all works because components or tasks are automatically canceled when like a component that it lives on or any kind of object it lives on is destroyed. Or in the case of components, they're unrendered. Sorry, it's tempting the devil by kicking this cord. Just one sec. So that's all cool. Hopefully by now it seems it's getting a little clearer how you can just take something that's asynchronous and sort of flatten it and make it and present it and basically write it as in a synchronous style, but inserting these little pauses in time whenever you need to. But there's still a problem with this, which is, what if I were to perform this task a bunch of times in a row? If I just click a bunch of times in a row, you start to see some jittery behavior, because nothing I've written in this code prevents multiple instances of this task from running at the same time. So if you remember that example of the async button that I started off with, the first thing it checked is, if I am running, checking some Boolean flag, then return early. But that would be kind of annoying if you had to write that in Ember concurrency, because that's such a common thing to want to be able to do, and Ember is all about finding conventions and getting everybody to adopt those conventions so that everyone doesn't have to write like boilerplate over and over again for very common tasks. So another way of putting this is tasks by default, like any action that might spin up a promise or anything like that, one way of putting it is unbounded concurrency, is that there's nothing stopping it from running infinite instances of itself. So something needs to come in and do that, hopefully something with the Ember concurrency API. So you can run multiple instances of the same task at the same time, nothing stopping you from doing that, and that's the default. And that's like the familiar behavior that most people are used to. And they only deviate from the behavior when they want to say, if is running, return early. And so if you want to have something that is constrained to only run one at a time, there's, generally speaking, even beyond Ember concurrency and just general JavaScript and programming in general, there's only 3 ways to do that. So the example from before is to check is running and return. And that also means that you have to keep track of this is running variable yourself if you're just using normal Ember or normal JavaScript. So return early is one way to keep something running one at a time. The other way is to use promises and then only do an async thing when a previous promise that was doing the async thing has finished. So you're basically making this promise chain, which this is actually a reasonably concise, terse way of expressing it, but it's not that obvious what it's doing, and usually when people do something like this, it ends up even uglier. And the other way that you can do this, if you're using an async library or paradigm that supports it, is to cancel the currently running operation and then start up another one. So that's just 3 ways: return early, make a promise chain, make a chain of events, or make a queue of events, or operations, or stop the current one and start a new one. But there's Ember, and this is a bunch of boilerplate. This is a bunch of like promisey acrobatics that you shouldn't have to like keep in your head. So Ember concurrency has this thing called task modifiers. And there's one called drop, there's one called unqueue, and there's one called restartable, and they correspond to the last 3 slides I showed. So this is sort of a timeline that I'll be using in the next few slides. And this is what things look like when you don't apply a task modifier. You have a task that runs for a certain amount of time and then completes, but there's nothing from running these things right on top of each other at the same time. So there's no constraints that only one of these run at a time because I haven't applied any sort of modifier to this task. So the first modifier that you can use is called drop. And it means drop as in any attempt to perform this task will be dropped while there's one already running. So if I tap a bunch of times, you see that all these attempts to run that task are ignored. You don't have to say, if I am currently running, return early. You just say, this is one of these tasks that drops if you try to perform it while it's already being performed. So that sort of enforces that these bars of a task lifetime don't overlap. And the second way is to unqueue, which is to say, like, let the previous one finish, but start the next one right away when it's done. So if you tap this a bunch of times, it's going to basically run one at a time. And none of them will be dropped, they'll just be unqueued. And at any point, you can cancel everything. All the unperformed ones will be dropped because a dropped task is basically a canceled task that hasn't even begun yet. And your third option is to say it's restartable. And I think this is the coolest one because it's really hard to do something like this with promises, even though the rest of the promise API is like pretty nice, pretty elegant. And so if you tap this a bunch of times, there's no unqueuing, there's no way you can unqueue because basically starting a new one means canceling anything else that's running. So it's the three different ways. Drop, unqueue, and restart. So how can you use these things to build out real features? And actually realize that this example doesn't use a task modifier, but it doesn't need to in this case. So one example, this is just an example of something that tasks make pretty nice. And the sort of generator flattened async way of writing things makes things pretty nice to look at. So if I hold down this increase button, it's going to start counting up or counting down, but it's going to accelerate. And if you had to imagine what this would look like, it would be a sort of like recursive next tick, run the same function again, but run it with a little bit less time. And, you know, I mean, chances are, if you've been doing JavaScript and Ember development and development of any kind, you could probably figure out how to do it, but it's not nice to look at. It's recursive in a very unusual way, and then you also have to deal with cancellation, all this stuff. But this is how you would write it in the sort of generator function syntax that Ember concurrency use. You know, start off at 400 milliseconds, and then you have a while true, so literally loop forever. But why is it not an infinite loop? It's not an infinite loop because it's going to get canceled at some point. And the thing that happens to be canceled is that this press and hold button component, which I don't have the code for here, but when the mouse is released, it's going to cancel the same task. So this is a pretty elegant way of doing non-trivial asynchronous stuff. So it goes in this while loop. It increments by whether it's a +1 or a -1. It pauses for the current amount of time, and then it cuts down the next amount of time that it's going to wait. So if it waited 400 milliseconds now, it's going to wait whatever 4 times 320 milliseconds the next time around, and then eventually get down to some small number, but not any faster than 50 milliseconds. So nice little trinket. The next example, which is something that's kind of like one of my motivators for even working on this stuff, was that I always felt that the RX observable library had a really elegant implementation for autocomplete. So if you're going to write an autocomplete search field, there's a lot of like little rules that you want to follow before it actually goes into production, which is that you don't want to literally hit the server every time that you press a key, because that's just going to overload the server. You're going to blast through API limits, or if it's a server that you own, you're just going to overwhelm it. So usually the solution is to wait a few milliseconds, 200 milliseconds or so, for the user to stop typing and then take whatever they've typed so far and then ask the server about it. But at the same time, if the user keeps on typing, I mean, depending on how you want to do it, but a common way of doing this is if the user keeps on typing after you've kicked off a web request to query some search engine or something like that, if the user starts typing again, you want to kind of ignore the results of the previous search request while you wait for the new one to come in. So just to demonstrate that this works, if I type in ASD, it's going to actually hit the GitHub API for repositories, but if I just kind of keep on typing and don't let enough time to go by, it's not progressively hitting stuff, but when I let go, it says, no results found. So the way that you can do this is to, we'll use a task, and you can say that this task is restartable. And there's a clever little thing that's happening here, because what does this task do? Well, first of all, it does have a guard to make sure it doesn't search nothing, but that's fine. That doesn't have to do with like asynchrony and concurrency. But then the first thing it does in this task is to say, pause for 250 milliseconds. And this is basically, if you've ever written I think Ember has like ember.run.debounce, but there's also like the idea of debouncing is a concept that just means like for every time you call this function, wait a certain amount of time where it hasn't been called to actually do the work it needs to do. And it's a way of just like preventing too much bursty work from happening all at once. In this case, you don't want to hit the server every time a user types. You want to wait a little bit and then go. So this pauses for 250 milliseconds, and then it makes a jQuery AJAX request, and it yields for it. And it turns out that the value returned from this is promising enough for Ember concurrency to know how to pause until the result comes back. Then the result comes back, it gets stored in JSON, and then that's what we return. And we happen to be using it in, this example uses Ember power select, which is kind of where this nice interface comes from. But the fact that it integrates pretty nicely, just as if you had used an action or defined the interaction with Ember power select, but the fact that you can use tasks instead is pretty cool. But to sort of come back to this, the fact that you said that this is a task that is restartable means that if anything happens in this span of time that you're in that initial 250 millisecond wait, it's going to cancel that, start over, and basically start that 250 millisecond wait over again, which means you basically made debouncing work. Like it's not going to get to this point, it's not going to query the server until 250 milliseconds has elapsed, and that's pretty cool. And if you wanted to change that debounce millisecond value depending on some other stuff, it's much easier to have it to do that with this kind of system than it would be to just use a strict like low dash debounce function or ember.run.debounce. So actually ember.run.debounce might actually support changing that, but I don't know how that actually works. So that's pretty cool. And this example I could go into, but it's not super important. It kind of gets into some nitty-gritty details. The one difference being that in this previous example, if you were to open the inspector and look at your network tab, you would see that none of these previous AJAX requests were being canceled, even though technically we could have taken advantage of that task cancellation opportunity to do that. And this slide, if you want to come back to it, just shows an example how you could do that by replacing the get JSON function call to jQuery with something that uses try finally in a clever way. Pause on the jQuery promise attached to the XHR object, but if it's canceled, it's going to hit this abort, which gives you a chance to cancel the XHR request. But if it's already run to completion, then abort doesn't do anything. So it's a clever little way of basically getting cancelable. Let's actually, maybe let me just show the network tab here. Sorry. So if I type this a bunch of times and I let the 250 millisecond time elapse, but then I start typing before the network request comes back, all these, I know this is small, but the red means it's getting canceled. It's not just getting black holed and forgotten about, it's actually conserving network resources and canceling any previous request it doesn't care about. So that's cool. It's really hard to do with promises without doing really hacky, sneaking around the promise interface to reach the underlying resource that the promise wraps. This is a newer example I wrote, but if you press and hold the button, you get a whack quake. And if you let go, it goes back to that. So I would actually, hold down and select pieces of code, but I just realized that it's gonna do this on me if I do that. But anyway, this is just a cool thing where you have a, where you've got another while loop within a try finally, using finally to reset the position and animate back to a certain place. But this also highlights a kind of nice API, which is like you don't have to attach an event listener or have another mouse down function tell this task to perform. You can just say on mouse down, cancel on mouse up, and it's very succinct. It doesn't really make you write a bunch of lines of code that interact with the task in any way. It's very declarative. Starts here, ends under these conditions, and behind everything, if the component were suddenly unrendered, then it would stop this task. So it's really the minimal amount of code that I could imagine trying to implement something like this. So some of this is familiar, some previous talks I've given, but it's been around long enough that it's kind of worth talking about, like what's going to be in store for this add-on. And I realized I didn't write a slide about this particular thing I'm about to say, but most people that have used Ember concurrency agree it's way better than using actions, just functions in the actions hash that you have to clean up after yourself from and be very careful when the component's lifecycle ends. I don't really think I've ever heard anybody, except in the rare cases where an action needs to do literally one synchronous thing and it's done. I haven't really heard anyone come back and be like, yeah, I tried Ember concurrency, didn't really like it. It's like everyone that uses it, it's way, you don't use promises anymore, you just use these tasks. It's like pretty simple. And so there's a possibility, and I haven't really talked to any of the core team about this since they've been mostly focusing on like Glimmer, which is good. But at some point, once more and more people have had a chance to use Ember concurrency, I would hope that it might be the sort of default primitive that you use instead of actions, and maybe even build more nicer things around it into the framework. Because there's a lot of parts of Ember that don't really know how to interact with an asynchronous thing that's cancelable. If Ember wants you to load all of your data and your model hooks of a route, but then you navigate in the middle of that model hook resolving, you might want to cancel that operation, but that's really messy to do. And it's one of these things where if there was this concept of cancellation, which isn't a problem that they've had to solve because promises were never cancelable, then I can imagine some really nice integrations that are better than what just comes with Ember concurrency add-on alone. So maybe someday it will be sort of the replacement for actions, but I need to sort of talk to people about that again. Separate from that is that a lot of people who've reported that testing Ember concurrency tasks is tricky, and as a sort of pedantic add-on author, I always come back and say, like, what were you doing before? Like, were you not implementing features involving time and polling and all this stuff that Ember concurrency makes easy? And I don't really know what the answer is to that. But for instance, if I have an example where this sort of thing, this asynchronous thing just implemented using plain old functions and a promise and a .then versus the Ember concurrency way that you would write the same thing, these two things do the same thing and they're just as difficult to test. Why? Because whether you're using a very explicit while true loop that goes on forever until a component's destroyed, or you're using this approach here where you call a promise and you use .then and then you say after the results come along, then 500 milliseconds later run it but stop it when it gets here, it's still a loop. It's still like a timer loop. And the whole reason this causes problems with testing is that the Ember testing library is smart enough to wait for pending timers to resolve before it lets your test assertions run. So what it causes is just this like infinite loop, and it seems to hang, and you don't really know what's going on. And then 10 seconds later, you get an error saying that it timed out. So that's kind of the interesting thing about this is just like what were you doing before all of that? And I think the answer is just either you weren't testing, which is fine because I don't test everything, or it just seems like if this is so easy to express now, why is it still really hard to test? So yeah, both call Ember run later in a loop, whether it's a loop via like recursion or it's a loop just via while loops in a generator function. So this is very hand wavy. If anyone was at EmberConf and heard Yehuda and Godfrey's presentation on Glimmer primitives, there was a Handwave icon between like every slide as they glossed over some details, but I'm going to do that again. So there's an idea that's been floated around, and it's based on some production apps that people have been using that use something very similar to Ember concurrency to solve this problem, like write things that have polling loops but need to be able to like be reasonably easy to test. And so one idea is to basically like, well, why don't you take this opportunity to, if it's hard, if you want to break this loop in some way, which you're going to need to do to like solve this problem, one thing that you could do is to imagine supplying a label to a timeout, which is something that means absolutely nothing if you're running code in production, but gives testing code a chance to reason about it, maybe listen out for a timer that's labeled, and then don't actually wait whatever 500 milliseconds or maybe 10 seconds or a whole minute or whatever it is, but actually look out for that and give you a chance to pause the test and say, okay, this timer fired. I expect the world to be at a state such that foo is 0. And then once I've run all the assertions that I want to do, I can return, timer.fire, and that is going to say, okay, let this run, let this do its thing, and then it's going to hit this timeout again, which is the same timer that it's looking out for, and then give you basically a chance to assert against the state of like every slice of this loop, every iteration of this loop. Very hand wavy at the moment because I'm sure you could poke holes in it, but this is actually getting pretty close to something people could imagine using. And if people are interested in this, there's a very active channel on the community, the Ember community Slack, the e-concurrency channel, where people talk about their gripes with Ember concurrency. But there's a lot of active conversation about how to make this stuff better. And I think we're getting very close to something. So this is something that's not quite ready, but is close. And it would probably be in the next release. And there's something else coming up. Oh, right, and I just wanted to say an alternative, like this is something that isn't really Ember concurrency specific, like whether you wrote the kind of recursive based timer loop, you still want something that is going to break the loop by selecting a particular labeled timer. And so this is something, if this problem were solved and ended up being a nice pattern for testing loops and unwinding these asynchronous infinite loops, then that's something that would span beyond Ember concurrency and probably just be like an add-on of its own. But we will see. The alternative, which I hope someone will actually, maybe if I have time to do it, I'll try it, but it would be nice if you could just sort of stub run.later and have a way to be like, okay, well, I know there's looping timers, so why don't we just go 5 seconds in the future. I would expect to see this like still connecting message because Ajax hasn't returned and all this other stuff, and just give you a way to like travel through time. And there's some libraries like RX observables do this in a very like they use something called like virtual schedulers, and it's got its own shortcomings, but it's a hard problem in general. But I'm hoping that someone will come up with either the sort of label approach or just a generic like freeze time, now go forward in time, and then assert against that, because without it you're just going to keep on running into these hanging test situations. Alternatively, you could also just, there's other cases where it's not a loop, but it's still like 10 seconds of some like banner that's supposed to display, and something that you could also do is just like, rather than hardwiring in 500 milliseconds, you could import some configuration and say, what is the generic like banner timeout that I use? And in production, it's 10 seconds. In testing, it could be 5 milliseconds or something. I've seen people do that, and it's not so bad. So completely unrelatedly, I've been having some good conversations with people at Frontside, and Charles in particular had a great talk at EmberConf about immutability and how you could envision state management as like, rather than objects with their properties changing over time via like object.set or this.set, it's really immutable objects in a series, and whatever is the current value is whatever you're currently pointing at. And it's something that's definitely caught on in a bunch of other UI libraries and frameworks and languages. The entire like Lispy closure language is based on immutable values, and this is going to be extremely hand wavy. And I think if anybody saw this and thought I was going to criticize Ember, I can't say that I or anyone else has really totally solved this and made it feel like Ember-y in a nice way, but definitely the front side people are close. I've been working with them to get hopefully a little bit closer. But presently speaking, Ember state management, I think when your app grows and grows and grows, provides a lot of conventions, but it kind of punts on some more difficult state management problems. It still relies a lot on like objects mutating other objects, but not in a very like encapsulated place, and it makes it really easy to change the entire world from anywhere in your app, whether that's a wise decision or not. And usually Ember forces you on a sort of happy path and kind of teaches you how to do this stuff better. But I think it gets to a certain point where it quickly falls apart and all the designs feel equally good because it's equally a little bit messy. So there's an opportunity for ember-concurrency to fill a certain void here that doesn't answer all the questions, but at least maybe like claws a little bit of messiness away from the sort of standard Ember way, if there even is one, for managing these tricky state management problems. So this extreme hand waving, I don't even like come up with a solution because it doesn't really make sense and it's very half-baked at the moment. But this is an example of why, even with ember-concurrency, stuff is still a little bit gross. No, you're not going to call mutable state and set mutable state like in sequence like this, but there's still this problem where like even if you've got a nice API for saying that this is a task that restarts every time it's performed, and then it calls out to child task, and this one calls out to grandchild task, and there's some elegance wins because it would look even crappier if you tried to do this with timers and just functions. But there's still the problem that like you might be deeply inside this function, which is called by, or this task, which is called by this task, which is going to, time out before it. And all of these things have equal access to the state on this component object. Like that's not great, It's making these distantly, deeply nested things away from the source mutable thing a little too easily mutable. And I'm hoping, and I've been working with some of the geniuses at Frontside, and I think we're actually pretty close to something nice, where ember-concurrency will give you a sort of alternative without being a drastically different API, where you can use these. What's good about ember-concurrency, these task modifiers, the fact that everything's like as declarative as possible, in a way that avoids a lot of boilerplate, but lets you is a little less direct, is a little more indirect about how changes or things reported or progress reported by where you are in a task to actually change the world. And I can say that we're close. I don't have a thing to actually put on the slide for you, just to know that if you've been frustrated by some cases where your Ember code got a little bit messy because just too many things are changing each other and it's getting messy to test, that we hear you. And I'm doing my small part to, at least if it has to do with the asynchronous stuff, I expect it to get a little bit better coming soon. So as I said, there's still a lot of like sideways mutation, even if the timing aspect of stuff is easier to reason about with ember-concurrency. But still a ways to go. So if you're interested in this stuff, or if you want to see what the rest of the world is doing, I think there's a few immediate things that come to mind. If you're in the most usually React world, even though some people have combined Redux with Ember, there's a library called Redux Sagas, which also use generator function syntax to let you write these seemingly sequential, synchronous looking things that deal with time, but they do the Reduxy thing where instead of mutating values or firing off actions over time, and they've got a story for cancellation, and it's very like composable, and it's kind of like both libraries, Ember-concurrency and Redux Sagas, came out pretty much around the same time, so I don't know what we were influenced by. They're both reading, but it just happened to come around the same time. The other thing is RX observables, kind of the biggest motivator, because I'd been, 2 years ago, I'd been like beating the RX observable drums and trying to really like get everybody in the Ember community to start using them because they're so great, but they also don't look anything like the rest of Ember, and they're extremely tricky, and their semantics are subtle and awkward. And anyway, there was basically, the feedback I got from everyone on the core team was basically like, 1, you're super annoying. 2, there's got to be like an Ember way to like make these like chain functions and composition seem less daunting because no one's going to want to use it in its present state. But still, it's still like a huge motivator, and it's fun to just at least go into this stuff and see how there are alternative ways to describe asynchronous processes that don't use the sort of Ember concurrency generator function approach to stuff. And thirdly, there's this thing, and what do you call it? There's a concept called communicating sequential processes, which is kind of the underpinning of the Go programming language. And it's the idea that a way that you can model your program is to have a bunch of these like really lightweight programs doing their own computations. They're very lightweight to spin up, and the way they communicate with each other is over these channels that you can pass to them. And so you can imagine like creating something that queries Ajax to be something that you spin up a process, you give it a channel to report the final value on, it does its Ajax-y things, and then it fires the result on that channel. And the whole Go programming language is based on that. And there's actually, all you need to bring that to JavaScript is generator function syntax, and actually the first version of Ember concurrency that I put out used a library called js-csp, which uses channels, uses stuff that seems very familiar to the Go language, but accomplishes similar things. And I just used like a subset of that to get, tasks and restarting stuff and all this different stuff working. So if you're interested in this kind of stuff, different ways to like express and reason about async, these are definitely the big ones. So that's all I got. You can check me out at Twitter at MACHTY, and it's also GitHub and whatnot. Also, you should look at ember-concurrency.com, because there's just all sorts of examples, and people tell me the docs are pretty good and pretty clear for, this should seem pretty familiar. But yeah, check it out. There's a lot of examples, and